These are the 6.2 notes for trig. We're going to be talking today about more right triangles. Our essential question, how do I find the values of the trig functions given a trig function? So they're going to give us a few of the answers, and then we're going to need to fill in the rest. So remember, we have sine, cosine, and tangent. And then their reciprocal partners, cosecant, secant, and cotangent. So we need to remember that sine and cosecant are always kind of paired up. Cosine with secant and tangent with cotangent. The first thing we want to do is label opposite, adjacent, hypotenuse. So I know that sine here is opposite over hypotenuse. For cosine, I have adjacent over hypotenuse. And if you notice now, I have all three of my numbers. The opposite is 1, the adjacent is radical 3, and the hypotenuse is 2. So I have all three of my numbers, which means I won't have to do any Pythagorean theorem work to find a missing side. Then I'll fill in the rest of my chart. Tangent is going to be O over A. So my O value is 1. My A value is radical 3. Now remember, we are not allowed to leave a radical in the denominator. So we will what we call rationalize the denominator. Multiply the bottom by radical 3. Whatever I do to the bottom of a fraction, I must also do to the top. The square root of 3 times the square root of 3 gives me the square root of 9. And the square root of 9, remember, is 3. So it's almost like those square root bars cancel each other out. And in the numerator, radical 3. For cosecant, you are going to flip the sign, the reciprocal of sine, so h over o. The h value is 2. The o value is 1, which then will divide out to just be positive 2. Secant is cosine reciprocal, h over a. H for this problem is 2. A is square root of 3, radical 3. And we'll work through the same process that we did on the tangent one. We'll multiply by radical 3 at the top and the bottom. Remember, radical 3 times radical 3 would give you radical 9, square root of 9, and the square root of 9 is 3. So again, almost like those square roots cancel out. Now for this one, the top part, if you notice, the 2 does not have a square root bar. So that 2 is going to come on the outside, and then the square root of 3, that 3 will stay on the inside. So you wouldn't actually multiply those together to get a 6, since 2 is not inside a radical. Right? And then cotangent would be adjacent over opposite. Looking back up at my numbers, I've got my adjacent as radical 3 and my opposite as 1. It's nice to have a 1 in the denominator because you pretty much just don't need it. Divide it out to get radical 3. All right. So the next part, we're going to introduce a negative into the mix. So for example, number 2, find the exact value of tangent. Notice they're shortening our work for us. We just have to find tangent, as opposed to the last problem we had to find 4 answers. We just have to find 1 here. Find the exact value of tangent. So we'll start by labeling O, A, and H. I know sine is O over H. Cosine is A over H. Now we need to make an important note off to the side. The hypotenuse is never negative. Hypotenuse is never negative. The opposite side could be a negative. The adjacent side could be a negative, but the hypotenuse side is always going to be a positive. So what that means is when I look over here on the second fraction, cosine of theta equals negative 3/5, the negative needs to either move to the 3 or the 5. I cannot move it to the 5 because 5 is the hypotenuse. So I'm going to scratch this out of the front and I'm going to relocate it to the 3. Again, you can't move it to the 5. 5 is the hypotenuse. Hypotenuse is always positive, never negative. So now I'll be able to find my answer for tangent. Tangent is O over A. So ka toa. So that toa part tells me the O over A. And my O is 4. And my A is negative 3. And there's my final answer. If you have a negative in the numerator or in the denominator, it is the same as having it out in front. So you could also write it as negative 4/3. That negative can move to the top, to the bottom, or in front. All right. Example number 3. Find the exact value of tangent and secant. So again, not all of them, but just 2 of these here. Sine, opposite over hypotenuse. Cosine adjacent over hypotenuse. And we've got 2 negatives that we need to deal with. So this first negative, instead of writing it out in front, we want to move it to the opposite. We can't move it to the hypotenuse because the hypotenuse is never negative. So we're forced to move it up to the opposite side, the opposite number. Same thing happens on cosine. Got to move it to the A because you can't move it to the H. All right, and then we just got to kind of figure out what we have. It looks like I have all 3 sides, opposite, adjacent, and hypotenuse. So we'll get to work. We'll do tangent first. I'll abbreviate it. Tangent of theta equals opposite, negative square root of 5 over adjacent, negative 2 square root of 5. And then some things are going to happen here. We are going to be able to cancel. So I'm going to actually cancel the square root of 5 with the square root of 5. And I'm going to cancel the negative with the negative, which leaves me a 2 in the denominator. Nothing in the numerator, but I will need a placeholder of a 1. So I get tangent is 1/2. All right, let's work on secant. Secant is cosine's reciprocal, so that'll be h over a. It'll look like we just took the cosine and flipped it. 5 over negative 2 square root of 5. All right, so unfortunately here I can't cancel the 5s because one is in a square root and the other one's not. So I will need to rationalize the denominator. So you multiply by just the radical 5. You don't need to also multiply by that negative 2. We'll get the same thing accomplished by just multiplying by radical 5, top and bottom. Okay, so what this gives me, these 2 right here, the 2 radical 5s, give me square root of 25. I know the square root of 25 is 5. And if I drop down that negative 2 in front, negative 2 times 5 would give me negative 10. Then at the numerator, I have 5 on the outside of a radical as well as a 5 on the inside of a radical. The inside and the outside of a radical pretty much never come together. So when I look at this ratio right now, I notice the outside numbers. I have a 5 and I have a negative 10. Because those are both on the outside, I can reduce those. And 5 over negative 10 would turn to 1 over negative 2. Can't really do anything with the square root of 5, though. That does not reduce the same way as the regular outside numbers do. So I'll get a final answer. I have negative 2 at the bottom. A 1 at the top, but I don't really need it. Just like you don't need a 1 in front of an x, you don't need a 1 in front of a square root. You can put it there if you'd like, but just not necessary. Here's our final answer. So a lot of review of some basic math skills that we have not done in a while. Remember, not all of them will be that level of complexity. Some of them are a lot more straightforward. Just depends on the problem. All right, on the back side of our packet, example number 4. What do I do if they give me a point, like an XY point? So first I want to talk to you about quadrants. When we have a axis like this, we have 4 quadrants. We have quadrant 1 up here, quadrant 2, quadrant 3, and quadrant 4. And depending on where the point lands, we're going to attempt to draw a triangle in one of those quadrants. So if the point lands in quadrant 1, right, if the x is positive and the y is positive, you would go forward in the x direction. Let me change colors for us. Forward in the x direction, up in the y direction, come back to the center. There's your quadrant 1 triangle. Now, if something was in quadrant 2, it means your x would be negative. So you go to the left, y positive, up, and draw that back to the center. For a point in quadrant 3, both the x and y would be negative, meaning you would go left and down. So something like -2, -3, right? Left and down. Quadrant 4, a positive on the x would push you to the right. Negative on the y would push you down. And then just attach that back to the middle. So I always refer to this drawing as a bow tie. Looks like the bow tie somebody would wear around their neck. That's always how I draw my triangles. Now let's talk specifically about our example 4. For the point 3, -4, find the exact values of sine, cosine, and tangent. So we're first going to need to start by identifying which quadrant this is in. So 3 is my x, 4 negative is my y. So if you thought about an axis, going forward would put me this direction, and going down would put me this direction, which means that point would land in quadrant 4. I'm going to draw an axis, and then I'm going to draw that triangle in quadrant 4. I'm going to put a little right angle symbol right there. Every time we draw one of these, I'm going to be talking about the angle right here. So always that interior angle. Then I can label. For my labels, this would be the opposite, my hypotenuse, and the adjacent. And then we'll put our 3 and -4 on there. So remember, if you were plotting a point, you would go forward 3 and then down 4. And then our goal is to find the hypotenuse. So in order to do that, we'll need to do Pythagorean theorem. A squared plus b squared equals c squared. C is the hypotenuse. So I can do 3 squared plus -4 squared equals c squared. And my goal will be to find the hypotenuse. Make sure when you square that -4 that it does become a positive 16. It's -4 times -4. Add those together to make 25. And at the end, we'll square root to find our answer of c equals 5. Then I take that 5 and I put it on where the hypotenuse is. Now remember, the hypotenuse is never negative, so I'm good to leave that 5 as a positive 5. Once we have the triangle all the way drawn out and all the sides are labeled with numbers, then it's time to actually do the answers. I need to find my answers for sine, cosine, and tangent. I'll abbreviate. Sine I know is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. See if you can fill those ratios, those fractions in. Right, so sine should be negative 4 over 5. Cosine should be 3 over 5. And tangent should be negative 4 over 3. All right, one more problem for us to tackle today. What about a problem where you are given a sine and then just one of the quadrants, where the quadrant is? So notice right here, they say theta, the angle, the triangle, is in quadrant, and notice they switched over to Roman numerals. So that's quadrant 2. I want to start by drawing my triangle in quadrant 2. And remember, anytime you draw a triangle, you want to make sure you set it up to look like this here, right? So every time you draw a quadrant 2 triangle, it should look like that. In order to help me do that, I will usually draw the entire axis and then out, up, and back down diagonally. There's your quadrant 2. All right, they tell me that sine is 12 over 13. Sine of theta, or the triangle, is 12 over 13. Sine I know is O over H. The angle that they're speaking of, the theta, is always in the middle, right where the little tie of the bow tie would be, in the inner section of that triangle, closest to that 0, 0 point. So then I can label my opposite, adjacent, and hypotenuse sides. Take a second and do that if you haven't already. Opposite, adjacent, hypotenuse. Now very carefully, we're going to put each of these on. When we do, we have to watch for invisible negatives. Watch for invisible negatives. So let me talk to you about what that means. As you're looking at the triangle, anytime you're going forward and up, your sides are going to be positive. But anytime you're going left or down, your sides are going to be a negative. So when I see a 12 for my opposite, I'm going to put 12 on for the O side, and then just make sure that it's actually a positive 12. Let's see, did my triangle go up? Yes, it did. If it went down, it'd be down here. Okay? So it did go in the up direction. That is a positive. And then my hypotenuse, 13, always positive for the hypotenuse. And then I just need to find my missing side. Back to Pythagorean theorem. I'll do this one pretty quick because I think you guys are familiar with Pythagorean theorem. And square root at the end to get 5. Now, when I go to put 5 on this triangle, I have to ask myself, is that positive or negative 5. Well, which direction did I go? Starting here, I had to go left to get to that triangle, which means that this 5 needs to be represented with a minus sign. So that's what we call an invisible negative. There was no negative on the 5 right there when we solved it. Only once we put it onto the triangle did we realize that it was negative because I went to the left. Now, once everything is labeled, O, A, and H, and all of them have numbers, then we can actually finally write our answer. Tangent is equal to opposite over adjacent. All right, so feel free to review this video as much as you need. You can ask me as many questions as you need. Good work today.